Okay, so compare to what you have, compare to the person next to you. Should I leave the free body diagrams up first? Or recheck your free body diagrams? So you have 500 newtons, you have the P. You have a normal between A and B that I called NAB. You also have a normal from the bottom, which I called NB. You have the frictional force between the bottom and the block B, and then you have a frictional force between A and B. Everybody did their table, right? So do your table. Yeah. Okay. You can put them together if you want. Yeah, you can put them together. So Lonnie asked on when you put the free body diagram for A and B, I put WA and WB as two separate forces, and she added them up together, and that's fine. I like to keep them separate just because when I draw the free body diagram of only block A, I'm going to put WA. And when I draw a free body diagram of block B, I'm going to draw WB. So I kept them separate and just drew them both. But you could draw one and just say WA plus WB. Jose?
And are we just assuming a direction for the friction on B?
Yeah, so that's a good point. I mean, we need to think about that, right? So let's take a look at the picture. So it's a really good point. When we do friction, we have to figure out which direction is the impending motion. Which way is it about to move? That's the only way I can determine which way my frictional force goes, right? So let's look at this. We have 500 newtons that's definitely held. So that block is held at 500 newtons. So when P is pulled, if P is small, what's going to happen? Nothing's going to happen. But if P is large, what's going to happen? B is either going to slide out from under A, and A is just going to drop, right? Or B is going to slide, and what's it going to do? Maybe bring A with it. So we don't quite know. We know that if P is small, nothing's going to happen, no movement. If P is great, we know block B is going to move relative to the surface. But we're not quite sure what's going to happen between A and B. Is A just going to pull with B? Or is A going to stay there while B is being pulled? And it depends on the friction between these two surfaces. And the force, of course. Force, of course. Does everyone agree that if P is great, B is going to move relative to the bottom? And does everybody agree we're not quite sure what's going on here? When could you use the friction equation? When could you say the friction is equal to mu s times the normal? It's during the static condition that it's just about to move. Those equations only work when there's impending motion. So where do we know that there is impending motion? No, between B and the block. It seemed to me that we agreed that when this is great, it's definitely going to move relative to the surface, but we don't know what's going to happen between A and B. So we know there's definite impending motion here, but we're not quite sure what's going to happen here.
Oh, you mean so A might also move?
With B. We're going to have to do all the math to figure it out.
But friction will need to be greater than
No, because 500 is not, it has an angle. It's not in the horizontal direction. Yeah. Okay, so let's take a look at this. So on the table, check your table. So did everybody have WA and WB in the table? Did everybody have NB in the table? Did you call it NB? Or maybe you called it N1 and N2? Okay. And then so that you should have two weights in the equation, you should have two normals in the equation, you should have two frictional forces, and a 500 and a P. So what is the total? Got it? Two W's, two frictions, two normals, a P, and a 500. So how many total unknowns do we have? 5 unknowns. So if we wanted to solve for all 5 of those unknowns, how many equations would you need? 5. But what unknown are they asking you for in the problem? Go back to the problem. They only want to know what P is. This is really important. We've covered it before. If we had to find all the unknowns, we would need 5 equations. But we only need to find P. So it would be awesome if we only needed one equation. But because there's so many other unknowns in the problem, we're going to need more than one equation. So looking at the free body diagrams then, what is the most efficient way of solving this problem? If you only need to find P. So talk to the person next to you. We have free body diagram 1, 2, and 3. Which free body diagrams would you want? Which equations would you use? Hey, David has a question that I'd like to talk about before you keep going. Everybody look, let's look at block B for now. Do you all agree that this friction should go that way?
Yes.
Because it's about to move that way. What about this? Explain why this is going to the left. We're starting with this. Right, but we didn't start with this, so let's start with this. If the impending motion is to the right, then it's going to slide, and there's the potential for block A. If block A stays there, B is still moving this way. Right, Jabin? If block is moving this way and A stays there, the friction's going that way. So does everybody agree that both of these frictions should go to the left? And then Chelsea, using your reasoning, then this guy has to go to the right. Okay. Okay, go back with the person you were speaking with and figure out what the most efficient way of solving for P is.